Actually. Okay, our next presentation will be on Zoom. Our next talk is by David Halland-Wood, Zachary Robinson, and Leon Chavez. The title is Experiences Building and Operating a Blockchain-Based Tasking Market for IoT Devices. Dr. David Halland-Wood is an entrepreneur and multidisciplinary engineer based in Brisbane, Australia. And he's currently the CEO of BitScore, which is a cybersecurity software company serving the space, defense, and government markets internationally. David also serves as an adjunct associate professor at the University of Queensland, and he advises several Australian space startup companies. But we don't have, I think, him online.
Oh, no, I think Bits is the...
Bits, okay, sure, yes.
Right.
Thank you.
Yeah, so unfortunately, David is unable to present today. I think he got caught up with other matters. James Fry will be giving the presentation on his behalf since he's more familiar with David's side of the work.
Yep, thanks, Zach. And can everyone hear me okay? Just audio check before I kick off.
Yes, we can hear.
Yep, cool. Okay, so yeah, thank you very much for the opportunity to speak here. As Zach just mentioned, unfortunately, David isn't here to present. I'll get on to what he's doing today a bit later into this presentation because it is actually relevant to this work. But here today, I'll be presenting what we've been doing in this space in terms of a tasking marketplace, particularly for IoT devices, and currently most of our prototypes are relating to kind of some of the space industry and that sort of side of things. So let me just move on. Okay, so our overall theory that we're presenting today is that it's possible to present tasking information to all sorts of different IoT and remote devices over a network in a way that we minimize technical details around how those tasks need to be accomplished. Now, we'll get into some of the ways we're doing that a bit later. The other stuff we're presenting here is the fact that this is a tasking market. We're allowing for multiple different devices to autonomously or semi-autonomously respond to these tasks directly back into the network. It allows a very high degree of cooperation to complete a lot of these tasks, which are provided by various operators depending on the industry, without having to use any form of strong AI to coordinate that sort of coordination between devices. And the final thing there is the solution that we're presenting today is backed by the current solution is backed by our enterprise blockchain as the technical architecture to implement this. So going into some more of the theory and where we came from in this. So we could see some problems in the space of tasking satellites. So satellites, there's a lot of satellites up there, and right now those satellites are often organized into various different groupings, constellations based on ownership and control mechanisms and so on. One of the big problems and big gaps that we see there is the fact that they are a scarce resource and there is a large degree of underutilization. So it might be the case that someone needs a satellite image over Sydney or wherever it may be, and there might be 3 satellites that are already in position to take that image and could take it within a minute or 2, but operators don't have the ability to contact those satellites or to issue commands to those satellites. This tasking marketplace would provide a means to get that task information to the entire pool of satellites such that the satellites which are more readily available to perform that task could do it with a lot lower latency and with a lot lower manual intervention. So where did we get to with this approach? So Dan Mandel at the NASA Goddard Space Flight Center proposed a solution in this sort of space back in 2017. So he saw similar problems. He also saw the fact that a lot of the control mechanisms for satellites right now have a lot of steps. They've got a lot of systems. There's a lot of complexity in even sending the commands up to these satellites, a lot of steps in the process. Sorry, I'm getting some feedback from Crichton. Yep. Okay, sorry. So there's a lot of complexity in the process of getting those commands up to the satellites. So he had a paper and a talk back in 2017 where he proposed a blockchain task marketing solution to allow for this sort of control of satellites using a blockchain and smart contracts. We have used that as some inspiration and taken it a bit further to, and I'll go into some of that, to genericize it a little bit. To genericize it a little bit. Sorry, just had my room be dialed, my apologies. To genericize it and allow for this to work for more than just tasking satellites. As well as allowing for the ability for it to work with devices which might be too low power to be able to properly commute a whole blockchain. We're also allowing for the ability for communication with ground stations, which will then sync into the blockchain system. So what is the approach that we're talking about here? So overall, what we're proposing is there could be any number of satellites up which are participating in this marketplace, and an operator communicating with a ground station would issue a task to this satellite market, specifying the input parameters that they need for this task completion. We have a tasking marketplace which then has sets of rules implemented in the market such that those input parameters are able to be verified regardless of the domain. In this case, it's just satellite, but we could have a number of different tasking mechanisms using the same market with genericized input parameters. The satellites would then be able to gain access to the information that that task is in the market. And if it were in a position where it could carry out that task, it could bid for that contract and execute it. The big win there is all of those contract executions will be stored in the immutable blockchain record, so everyone can see what's going on, and also it vastly increases the utilization of these very, very scarce resources. So our overall goals here. So what we wanted to achieve is this tasking market. We wanted all of the different assets to be still under the control of their owners. One of the important notes here is we're not directly issuing commands to these resources. What we're actually doing is we're issuing the task to a marketplace, and then the devices themselves are bidding and deciding which tasks they need to take up. So it still allows for control of assets by the various asset owners in the fact that it is still their end device that will have the final say as to whether it will carry out those commands, and they could still override it, or they can write their own code in terms of how and what tasks they wish to accept in this marketplace. So that means that those end network edge assets can choose conditionally to participate based on the constraints both in the market and their own business constraints depending on the organization. It also allows those assets to share tasking across multiple different domains. So it's entirely possible that a single task might pass through several different stages where different devices need to pick up that task and perform their part. And again, a large part of this is driving utilization of a scarce resource. one of the obvious questions here is, why is it blockchain, right? Now, a lot of these industries that we're initially targeting are highly regulated industries. So one of the things that blockchain gives us in this space is it's that immutable log, the record of everything that's going on. And that's very, very important for a lot of these government agencies who have these assets, being able to identify what has happened and when, and exactly the steps taken. And we believe using blockchain for that gives us a lot of power and a lot of ability to prove the steps that have been taken along the way. So, going into our specific implementation. So BitsCore is a company that has a number of different blockchain-based solutions. So we have a number of components that fit into this space. So we have our BitSync solution, which is forming the information storage portion of this, which would be for retrieving details of some of this, like the more complex details of various tasks. We have BitsAuth, which will provide a system for multi-party authentication. So that's very, very useful in cases where an asset might need to be more controlled, in the fact that someone could issue a task to a market, but it wouldn't be able to be accepted necessarily until someone has approved it. And that all works in the blockchain as well. And this latest thing that we're talking about primarily in this talk is, and the name is currently pending, Events, or Enhanced Virtual Network of Tasking Systems. So the main new thing we're presenting here is Events, which is this tasking marketplace. And all of these things work together on top of our private enterprise BitsCore blockchain network. But there's no reason why the same sort of system couldn't hook into any core blockchain platform. The design is such that we just need a system that will guarantee us consensus and guarantee our log of transactions, right? So that's another one of the benefits. We could be relatively agnostic to the specific platform that we're on, which is useful in cases, again, it's a highly regulated environment. There are cases where a company or a government might want us to implement this on top of their own private blockchain so that they can secure their assets internally properly. So next, I'm going to go on to what some of the experiments we've done with this so far. So one of the cool things that we've had the opportunity to do already is we have run a tasking market, tasking a Raspberry Pi on the International Space Station. So we had our tasking ground station running here in Sydney, and we were providing tasks to a Raspberry Pi box on the ISS. And that was over a basic TCP link at this point in time. But what we were doing is we were tasking this Raspberry Pi to provide us with updates on various different telemetry measures that we could access. It's still in prototype phases at the moment, but the fact is that we managed to successfully register tasks in the network and receive responses back. And that was a very exciting opportunity there. Additionally, we have run the same tasking market over a TCP/IP channel to a rocket as part of a rocket launch. And over on the right there, that's a picture of David and Leon, who unfortunately can't be here today, at the launch site with Black Sky Aerospace. So for this experiment, we had our payload, effectively end node on our payload, loaded onto a Raspberry Pi as part of the rocket's payload. And what we were doing is we were tasking this payload, even during the rocket launch, to send telemetry stats, as well as periodically take pictures. So we would give it tasks to take pictures as the rocket was launching, and it would take pictures and store it on its onboard storage. So there are still things that we're learning here in terms of overall communications challenges, but the core tasking market system worked very, very well in this space. And the final experiment that I'd like to talk about today, and it's also the reason why David isn't with you there in Brisbane giving the talk, is the experiment that we've been doing with Australian Droid and Robot for an invitation-only demo to the Royal Australian Navy. So they're out there today, either on a dry dock or on a boat, assisting ADR to use our tasking market to task their live drones as part of some mock exercises. So they have Raspberry Pi devices hooked up to these drones, which can control the drones. And we've defined a number of tasking interfaces in a domain for them. So this is demonstrating some of our ability to have the tasking market be a bit more generic in the fact that we're not giving specific commands. We're defining a problem domain in the tasking market itself, and we're allowing devices to respond to that. So out there today, they're running some of these drones through some exercises in the fact that one of the drone is responding to tasking market tasks to do sonar sweeps. Another one is responding to tasks where it is having to perform some visual surveillance of a location. And all of that has been going fairly smoothly. There's still some stuff that we're working through with that, but overall, my understanding is it's been quite successful today so far, and it's been a fantastic opportunity working with them. So overall, some of our experiences there is we feel that the fundamental tasking model and the way in which we can validate and prove some of the inputs and outputs to the system has been working very, very well. So the final slide I've got is talking about some of our work in this space. So I've got some links to some papers and some other stuff which is related to this work, which you're welcome to have a look through. And I would then open it up to some questions and we'll see where we go from there. And I might need someone in the room to relay the questions. I was having some trouble hearing questions from the room, if there are any questions.
Sure. Any questions? Yes, yeah, sure.
Hey, James, can you hear me?
Yep.
All right. Yeah, thanks for the great talk. This application is operating in an intermittently connected network environment because satellites often, times lose connectivity to the ground-based stations. So therefore, when we are trying to achieve consensus or come to agreement in these kind of partitioning networks, it gets really challenging, and there is a possibility for forking and all that in this type of environment. So you briefly talked about communication challenges. So are you already looking into handling partitions or intermittent network connectivity in your applications?
Yep, so that is one thing we've looked at a bit. So one of the changes that we've made, one of the enhancements we've made beyond what Dan Mandel's work was going on, was that we have the ground stations in there. The blockchain isn't just in the cloud, it's achieving consensus with the ground stations, and some devices are just communicating with the ground stations directly. So you're right, there are definitely some challenges in that space, but we are working through that. And did you want to add anything in there, Zach? No, you're on the call still.
No, yes, because particularly with satellite-based assets, you can only expect direct network communications for blocks of time, then it'll go like radio silent for a little bit. And so in those cases, the owner who owns that satellite has ground station who's running the consensus mechanism for them. And then the satellites themselves will route through the ground station that they trust, who's usually the owner.
All right, yeah, thanks for the clarification.
Any more questions?
Yes. Got a question.
So you mentioned Raspberry Pi a lot. Are there space qualified Raspberry Pis, or how does it in space? How does that work?
Yeah, I mean, it's an interesting space. You find Raspberry Pis all over the place. So we've got Raspberry Pis in rockets. We've got Raspberry Pis on the ISS. Again, this is currently in prototype phase. So there are any number of other devices, but it's interesting to see Raspberry Pis all over the place. But Zach, were you going to say something there? You're on mute.
Yeah, one of the interesting points is that the Raspberry Pi that we're given access to on board the International Space Station, one of the original tests it was performing was computational integrity in the effect of radiation clipping bits on the hardware itself, and it seems like that within its a Faraday cage it operates in with a direct comm link out, that it was successful in doing that experiment. So not officially space certified, but they work. So we'll take that.
Thank you. Any more questions? Thank you again for the nice talk. Are we going to continue with Shu Fang's presentation? Let's see.